So how are we going to solve this quadratic equation by graphing? Well, fortunately, it just takes a little review of what we've been working on the last couple days here. We've just got to graph this equation, and once we graph it, if we graph it correctly, we should be able to see the solutions. But we're going to list out some steps for you here to help us keep track of how to graph this and to find some key places or key points or key equations that we can plot and graph such that we can start to see the picture of our parabola, of our quadratic equation being graphed. So the first step is to calculate the axis of symmetry. All right, so we're going to do that here. Axis of symmetry. And I might start abbreviating that as AOS, axis of symmetry. And recall the equation for that is x equals the opposite of b divided by 2 times the a value. That's a little formula really that we need in order to figure out the axis of symmetry. Remember, an axis of symmetry is a vertical line that splits the graph in half. Anytime you have a vertical line, you're always going to have an x equals equation because it will always have the same x value if it's a vertical line. So we're talking about this b and a value. Recall that the b and the a value comes from the coefficients of each one of these terms. So the coefficient of x squared, remember there's like a 1 in front of that x squared, and then we have a 2 in front of the x, and then we have this minus 8. So those are our coefficients, what our a value, which is 1, our b value, which is 2, and our c value, which is negative 8. So we're going to use those, and really we just need the a and the b value for this part of our work. So let's just plug that into our little formula here. So x is equal to the opposite of b, so that negative sign will always be there, and then we'll put the b value inside the parentheses. So the 2 goes in there, and then 2 times the a value. A value in this case is 1. So let's just simplify that. So that'd be negative 2 over 2. Negative 2 divided by 2 is negative 1. So the equation for the axis of symmetry is x equals negative 1. So what does that mean? Well, on our graph here, what we're going to do is we're going to put a vertical line through the x value of negative 1. So remember, negative 1 would be to the left of the 0, 0 point. And so this dotted line, I'd like you to make a little dotted line here, just like you've been doing the last few days. This is our essentially line of symmetry that goes right down through the middle of our parabola that we're going to graph. Okay? So the next thing is we're going to find the vertex of our parabola, which remember is like either the bottom or the top, the minimum or the maximum of our parabola. Now the vertex of our parabola, we already actually know the x value of that vertex because it's always the x value of the line of symmetry. It's always that value in the line of symmetry because we know that the line of symmetry goes right straight down through the vertex. What we have to do is we have to figure out the y value of the vertex. And to do that, we're going to have to plug in that x value into our equation. So let's think about that equation as a y equals equation. So y equals x squared. So I'm going to put negative 1 squared. Remember, I'm taking that negative 1 from the vertex and just plugging it in for x. Plus 2 times x, so 2 times negative 1, minus 8. Let's simplify that. Negative 1 squared is 1. 2 times negative 1 is 2, negative 2, sorry. 1 plus negative 2, minus 8. And 1 plus negative 2 minus 8 turns out to be negative 9. So negative 9 is the y value of our vertex. So the vertex is negative 1, negative 9. So let's plot that on our graph. So negative 1 and negative 1, 2, 3, 4, 5, 6, 7, 8, 9 is right there. Now we know that that is actually going to be the minimum, the bottom of our parabola, because if you look back up here, we know the a value is positive up here. So we know that this parabola is going to open up. Okay? So the next thing is we're going to figure out the y-intercept. Now, fortunately, the y-intercept might be the easiest thing to figure out because the y-intercept simply comes from the c value of our equation up here. So the -8, the c value, is the y-intercept. So remember, that's really saying that the coordinates of the y-intercept are 0, -8. Remember, a y-intercept point always has an x value of 0. So 0, -8 will be right here. All right. And since we know that the line of symmetry goes right down through the middle of our graph, we can actually just reflect that point on the other side of the line of symmetry and put the point right here, which happens to be -2, -8. And we're going to start to use that to formulate our graph here. So now we're going to locate where the x-intercepts are. So this graph is going to be opening up. And when you have an a value of 1, you're going to have this pattern that will always hold true. And so we'll notice that we went from the vertex over 1 up 1. And if you have an a value of 1, you're always going to have the same pattern of over 1 up 1 for the two points that are immediately adjacent to next to the vertex. So the next point will actually be over 2 and then up x squared. In other words, up 2 squared. So 1, 2, 3, 4. And then over 2 to the left, 4. We're just going to reflect that point. And then if we go back to our vertex, the next point will actually be over 3 and up 3 squared. X squared or 3 squared would be 9. So that's not something we've talked a whole lot about. I'm just mentioning it here because what ends up happening is we can see that those 2 points end up being where our parabola is going to cross the x-axis, and therefore those 2 points are going to be our solutions. So our solutions are going to be right here and right here because those are the x-intercepts. So the solutions are going to be x equals 2 and x equals -4. So -4 and +2 are x-intercepts. In other words, the point 2, 0 and the point -4, 0. Now, I kind of knew the pattern for that and knew that it would end up being at 2 and -4. If you were just sketching this in at this point and you didn't know it crossed exactly at 2 or exactly at -4, as long as you were relatively close, I think that's what we're going for in this case. However, what you could do is you could graph this on a graphing calculator or on Desmos. You could actually put it into Desmos and you can see what it is. So we're going to actually use Desmos for the next one. And if you want to go through all of the detail that I just did, which is what I would like you to try on the practice problems, you can certainly look at the key for this that we're going to provide and see the detail. But I also want you to know that you can use a graphing calculator to find a lot of this stuff. So let's actually do that for our next one. Let's look at this and, okay, I'm going to note -x squared plus 4x minus 3. So let's just keep that in mind. And you can head over to Desmos too. And let's go ahead and do that. So you can either go to desmos.com or get the app, download the app for Desmos. And when you open it up, let's just enter in that equation. So -x squared plus 4x minus 3. So plus 4x minus 3. All right. So there is our parabola. I want you to notice a few things now because it's essentially graphed for us here, which is awesome. And you could do this for any of your parabolas to check your answers. But you'll notice that the line of symmetry is going to go straight down through x equals 2. Notice that our vertex is at 2, 1, and that our solutions, let me see if I can get these points to pop up. All right, so there's our vertex at 2, 1. And notice we actually see our solutions are 3, 0 and 1, 0. And wouldn't you notice, also, we have our y-intercept down here. So we really have all of the pieces of our parabola. And so let's just remember those as we go back to our graph and see if we can essentially just plot those. And in that way, we could maybe kind of bypass some of our formula work here. Just because I want these notes to not be too long for you, I'm not going to go through that entire process again. But if you would like to see that all done the way we did it in the first example, then feel free to look at the key that I'm providing. However, the axis of symmetry, I'm just going to abbreviate it, AOS, this time. Remember from our graph that we just looked at, the axis of symmetry went right through x equals 2. Okay, so let's graph that. So here's 2. You can flip back to our graph that we just did if you want, just to see that we're doing this correctly. All right, and then we had our vertex. So our vertex, recall, was at 2, 1. Again, notice the x value of the vertex is always going to be the value that we came up with for the axis of symmetry. And then to find that y value, you could plug 2 in for the equation here, into x for the equation, and work that out. But since we just saw it from the graph, we're just going to use that. So there's our vertex at 2, 1. The y-intercept, we didn't really need to look at our graph for that one. We know the y-intercept comes from that c value, and so we know that's -3. In other words, the point 0, -3. So we'll graph that point here. And then the other piece was that we saw our solutions on our graph were going to be at x equals 1 and x equals 3. So 1, 0 and 3, 0 were our two solutions. And let's just go back to our graph real quickly. See that it's at 1, 0 right here and 3, 0 right here. That's where it crosses the x-axis. So those are our solutions. And so let's go ahead and plot those. Oops, let's go with that. 1, 0 and 3, 0. And let's also reflect that y-intercept value over to the other side of the line of symmetry over here. So notice it's 2 units to the left of the line of symmetry. So we're going to put another point over here because I know that this is perfectly symmetric. And so now we have all the points that we need in order to graph our parabola. Notice this parabola is going to be facing down because our a value is -1 over here. Remember, our a value is -1, our b value was 4, and our c value is -3. So that a value tells us it's going to be flipped upside down. Notice that pattern also with our points from the vertex. From our vertex, we went kind of over 1, down 1 on each side of the vertex to get to those first set of points, and then over 2, down 4. We went down this time instead of up. But we can see all of our values that we have, and we can also see the x-intercepts or the solutions. So once again, I went through a lot more detail in the first problem. I'd like you to get used to doing that because we're going to expect you to be able to do that. But also use Desmos as a check for whether you are doing it correctly, because it's very simple just to type the equation in there. All right, so please proceed on with the couple examples that we have here. So just like the first couple pages here, our first couple examples, now you try a couple on your own. And then don't forget the little reflection at the end. We really would like you to be writing your little explanation, your rating down here, and to give us some feedback and to give yourself some feedback on how this was going.